A-Level Statistics, An Introduction to Probability. Let's have a quick review of GCSE probability. Now, probability measures the likelihood of something happening. And probability is measured on a scale of 0, which is impossible, to 1, which is certain. So if we draw out a scale, we see at 0 it's impossible. When we're near 0 it's unlikely. Halfway along the line we've got even odds, or 50-50. As we move further along the line we get quite likely or very likely, and when we reach 1 it's certain. Now, there are some words we need to define: experiments, events and outcomes. When we do something like tossing a coin or throwing a dice, this is called an experiment. Now, when we do an experiment, various things can happen. For example, if we throw a coin, it may result in a heads or it may result in a tails. And tossing a dice might yield a number from 1 to 6. Now, each possible result is called an outcome. So the outcomes of tossing a coin are heads and tails. For the dice, the outcomes are 1, 2, 3, 4, 5 or 6. If each possible outcome has the same probability of each of the others, then the experiment is called unbiased or fair. We can say the selection is random. Outcomes are not usually equal. If we consider, is it going to rain tomorrow or not? In some places it rains a lot of the time, in other places it hardly rains at all. However, we will mostly be considering unbiased situations. Now, an event is a selection of outcomes put together. If a dice is thrown, getting a prime number is an event. To get a prime number, we must get a 2 or a 3 or a 5. Now, for short, we write P followed by a brackets to mean the probability of getting whatever's in the bracket. So P6 means the probability of getting a 6. P even means the probability of getting an even number. Now, if all outcomes are equally likely, then we have the probability of an event, P event, equals the number of outcomes in the event over the total number of outcomes. Note, if A is an event, then A dash, or the complement of A, is the event that A does not happen. So, the probability of A plus the probability of A not happening is equal to 1. It is certain that either A will or will not happen. Now, if an experiment is repeated, then each time it's done, it's called a trial. If we get a result that we want in a trial, then the trial is said to be successful. Now, if a trial is repeated, we say the relative frequency of an event is the number of successful trials over the total number of trials. The relative frequency can be taken as an estimate of the probability. Also, if a trial is repeated, we say the expectation is equal to the probability of success times the number of trials. So the expectation is an estimate of the number of successes that are likely to occur. Let's look at an example. A bag contains 5 red marbles, 7 blue marbles and 3 green marbles. A marble is chosen at random. Calculate the probability of getting a blue marble. Well, to solve this, the probability of getting a blue marble is the number of blue marbles over the total number of marbles. Now that's equal to 7 over 15, so that's our probability. In part 2, we're asked what's the probability of getting a red marble. Well, this is equal to the number of red marbles over the total number of marbles, which is 5 over 15, or we can write that as 1/3. In part 3, we're asked what's the probability of getting a red or a green marble. Well, this is equal to the number of red and green marbles over the total number of marbles, which is 5 plus 3 over 15, or 8 over 15. In part 4, we're asked what's the probability of not getting a red marble? Well, the probability of not getting a red marble is 1 minus the probability of getting a red marble, which is 1 minus a third, or 2/3. Okay, let's introduce a new idea, mutually exclusive events. Two events are said to be mutually exclusive if they cannot both happen together. For example, when throwing a dice, the events, getting an odd number and getting an even number, are mutually exclusive. They cannot both come up on a single throw of a single dice. However, getting an even number and getting a prime number are not mutually exclusive, as 2 could come up and it's both even and prime. So, if we have two events A and B which are mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B. Let's look at an example. If we take a number at random from the numbers 1 to 10, what is the probability of getting a multiple of 3 or a multiple of 4? Well, to solve this, since there are no multiples of 3 and 4 together below 12, the probability of getting a multiple of 3 or a multiple of 4 is the probability of getting a multiple of 3 plus the probability of getting a multiple of 4. Now there are 3 multiples of 3, 3, 6 and 9, so the probability is 3 over 10. And there are 2 multiples of 4, 4 and 8, so the probability is 2 over 10. Now we can add those and see that the probability of getting a multiple of 3 or a multiple of 4 is 5 over 10, which we can write as a half. Let's also have a quick revision of sets and Venn diagrams. Now we can represent a probability experiment with a set and a Venn diagram. The universal set, which is a curly E, is the set of all outcomes. Any event can be written as a subset A, B, etc. of the universal set. The individual elements of the set are the individual probability outcomes. Now in a Venn diagram, the universal set is represented as a rectangle and the subsets are drawn as oval shapes inside the rectangle. So if we've got a universal set with two sets inside, A and B, we can shade in the set A. We can also shade in the set that's not A, the complement of A. Now that's everything that wasn't shaded before. If we want A union B, that's everything that's in A or in B or in both. And the complement of A union B is everything that has not been shaded in A union B. If we shade in the intersection of A and B, it's the part that is inside A and inside B at the same time. And the complement of A intersection B is everything that wasn't shaded in with the intersection. Now let's have a look at an example. A digit is selected randomly from the list 1 to 9. Now A is the set of prime numbers, B is the set of even numbers, and we have to place the numbers in the Venn diagram. Well, to put the numbers in the Venn diagram, 1 is not even and it's not prime, so it goes outside the two ovals. 2 is even and it is prime, so that means it goes in the middle section, the intersection. 3 is prime but not even. 4 is even but not prime. 5 is prime but not even, and 6 is even and not prime. 7 is prime but not even. 8 is even but not prime. and 9 is neither even nor prime, so it goes outside the two ovals. In part 1, we're asked to calculate the probability of A. Well, if we look at the set A, it's got 4 elements inside and there are 9 altogether. So the probability of A is 4 over 9. In part B, we're asked to find the probability of B. For the probability of B, B also has 4 elements inside it, so the probability is 4 over 9. In 3, we want the probability of A union B. Now altogether there are 7 elements in there, and so the probability of A union B is 7 over 9. In part 4 it's slightly harder. We want the probability of not being in A and not being in B. Well, if it's not in A and it's not in B, then it's outside of both of those, and there are only 2 elements that are outside, so the probability is 2 over 9. In part 5, we want to work out the probability that it's in A and at the same time not in B. Now we can see the shaded region that's inside A and outside B, and there are 3 elements in that, so the probability is 3 over 9, or that cancels to 1/3.